Ege Üniversitesi Bilgisayar Araştırma ve Uygulama Merkezi ve Ege Üniversitesi Mühendislik Fakültesi Bilgisayar Bilimleri Mühendisliği'nin organize ettiği seminerimize hoş geldiniz. Bu seminerde Avrupa Üniversiteler ve Araştırma Kurumları'nın bağlı bulunduğu, EARN projesi adı altında bağlı bulunduğu network'la ilgili bir tebliğ dinleyeceğiz. Bu tebliği bize bu projenin koordinatörü Sayın Alain Auroux, is it true? Takdim edecekler. Avrupa'da ve tabii özellikle Amerika'da çok yaygın olarak her türlü organizasyon bir ağ içerisine girmiş durumda. Türkiye'de henüz böyle bir ağı özellikle üniversite ve araştırma kurumları olarak bağlayabilmiş değiliz. Bundan bir yıl evveline kadar üniversiteler tüm kurumların önünde ve güçlü bir şekilde adım atarken bugün özel kuruluşlar bizi geçtiler ve önümüzde hızla gitmeye devam ediyorlar. Bugün bankalar ve diğer özel kuruluşlar maalesef artık bizim örnek alabileceğimiz bir takım uygulamalara girmeye başladılar. Ve Türkiye bugün üniversitelerin önderliğinde yapılan çalışmalarda başarılı olurken bugün örnekleri artık özel kurumlar bize göstermeye ve öğretmeye başlıyorlar. Bu nedenle geç kalmış olan bir ağ projesinin bugün Türkiye'de uygulama şansının tartışılacağı bu konferans gerçekten çok yararlı olacağına inanıyorum. Ve bu konuyla ilgili bize bilgi aktaracak Sayın Mr. Auroux'u konuşmacı olarak davet ediyorum. Please come here and explain. Kendisine şimdiden teşekkür ediyoruz.
Okay, thank you very much, Professor Manas, and good afternoon, ladies and gentlemen. The purpose of this presentation is to introduce computer networking, and my plan is first to describe several activities on computer networking, both in Europe, in US, and also to describe what has been done as an example in IBM for computer networking. This will be a pretty long introduction to the most interesting part of the subject, which is how this is implemented in Europe and how this could be interesting for your country and how it could be implemented in Turkey. So, is it, can you read? So, I'm sorry if you cannot read, I will try to not to use these charts. Okay, so this is just to tell you the subject, which is networking particularly in academic environment. What is the need, first, what is the need of networking, and which kind of network could we find? As we all know, exchanging information is more and more important in the world we are living in today, particularly in the fast-moving exchange of ideas like universities. It is not possible, it has never been possible to live and to work just alone, but it is more and more difficult, and it is more and more important to be able to exchange information with colleagues between different universities inside a country, but also between countries. So, to allow the exchange of information using computer, two types of networks may be provided to, let me say, two families. The first family of networks is called local area networks and is usually used to connect people working in the same location, same campus, for example. This is the first possibility for networking, and this is not the objective of this presentation is not to present local area networks, but it is to present what is called wide area networks. A wide area network is a computer network connecting in a very wide area, a country, a continent, or even between continents, computers all together, allowing them to exchange information. And obviously, a local network may be part of a wider network, of a wide area network. So, as I said, I would like to start with some past experience taken both from universities, and I will start with US universities where some networking efforts have started a few years ago, and also in Europe. I will take a non-academic example by describing the IBM internal network. So, also, please do not hesitate to interrupt me if my English is not good enough, if you do not understand it. I know that it is not good. And also if what I'm telling you is not clear. So, no, wrong way. Okay, I would like to start. No. Describing three major networks which have been built in the 70s or early 80s in the United States. The first is called Arpanet, and you probably have heard about the ARPA project. It is a project sponsored by the DoD, Department of Defense of the United States, linking all the universities being subcontractors for this department. Another network is CSNet, and I will briefly tell you what it is, but I will spend more time on the third one, which is called BitNet. I will spend more time on this third network because it is, let me say, the brother of the network which is presently being developed in Europe, namely EARN. So, so I'm starting by the last one, because I will spend more time on this network because, as I said, it is the one which is closer to the European Academic and Research Network. First, what is the meaning of BitNet? It means because it's time, and it is a name which has been given by the founders. They thought when it started in 81 that it was really time to have such type of academic networking, and I will tell you why it is different of the predecessors. And this project started very quickly in end of 81. It started very quickly because it was using something which was already available. I mean, a software and hardware which were spread all over the country and very easy to use. Both hardware and also software. It used very simple protocols. It was economical, which is very important, but also with fixed cost. What I mean is, when starting, it was possible to know exactly what the cost would be. And particularly in this academic environment, it is very important. It was easy to expand. It was easy to join the network. And as it is easy to join, so the expansion is easy. Simple to use, as a consequence, the administration of the network was very easy. So as I said, it started in early, maybe it's too high. Yes, what is the purpose of this kind of network? It's, here you see listed few advantages, like helping writing books, joint authorship of not only books, articles, research proposals, etc. And access by visiting scholars, which means that if you are not in your location, you are able to access your own data. It may allow you to access specific database and to access special software in some case, if you have access to it, if it is built in another location, etc., etc. Now I would like to show you, if possible, a map which gives you the center, the heart of the network, if I could say that. It started in this CUNY, which means City University of New York University. And this university has several colleges, all the colleges being linked to the central CUNY location. but this is just a small part of the network. Now, if you look at the global network in the States, so you see that CUNY is still one of the most important nodes with all the colleges which I showed you 1 minute ago, but that it is linked to most of the US universities. And you see here what I could call a very special link, because it links this US network to the now growing European equivalent EARN. Now to show you where it is developed. That's a little bit difficult to see. It somehow it reflects the academic US environment, with many things, a big pole here on the East Coast, another pole here on the West Coast. But today, as it started on the West Coast, on the East Coast, I'm sorry, so it is not yet developed as much in the West. Yes, maybe it's interesting to see on this chart how the network has developed. And I think it's important because the way EARN is developing is very close. All the cities which are here, I mean, all these points, represent one center with one computer, or maybe with several computers. Let me say they're all equal. I mean that you have seen that CUNY, for example, was a bigger center. It does not mean that CUNY is more important, quote unquote. It means that it has more links and needs more telecommunication equipment. But it is not a hierarchical network. All the functions are the same in all the nodes, with some, the programs which are run are different from one node to another. Exactly like two computing centers are never running exactly the same programs. But from the network point of view, all nodes are equivalent. Suppose that now Mr. A, which is University A, which is in this state where nothing, no node exists today. So what does the university? The university then runs a line, a telecommunication line going to the closest node, here, or here, I don't know. And that's all. Not quite, but almost all. It has also to run a software allowing the networking. And by networking, I mean mainly exchanging files. So the rules are very simple. I mean, the bitnet rules are very simple. If a university wants to join the network, then the university leases a telecommunication line with two modems, two telecommunication equipments at each end, and run the needed software. The next step, which comes in parallel, is updating routing tables, just to tell all the rest of the world, I am here, this is my address, and that's all. Let me comment on what I've said previously, saying if this network has spread very quickly, is because the cost is not only not very high, but known in advance. It is known in advance because the only cost from the telecommunication point of view is the cost of the leased line. As you certainly know, the cost of a leased line is a fixed amount of money that you pay each month. So this is Canada. Very difficult to see because this network called NetNorth, which is an extension of BitNet, is just starting in this area of Canada. So, what is the purpose of this network? What is it possible to do with it? It is possible to exchange messages first, like the mail. It's, let me say, it's a very fast mail. But to me, this is not the most, it could be a visible part of the network, but certainly not, for me, the most important. Most important will be to exchange files, programs, books, things like that, which is here the second point. It is if two people in two different universities are working on writing a book together. So instead of exchanging it many times, visiting themselves many times, it is possible to do it on the network with a much lower cost and on a more effective manner. Interactive messages is not, to me, a very important application. What I mean by interactive logon is the possibility, when being on a computer, to access the resources of a remote computer. For example, suppose that here in Turkey you have a network, so some people coming from Istanbul could, from Izmir, access the resources of their Istanbul computer using a terminal connected to the Izmir computer. As soon as you do that, I mean the interactive logon, so you have access to remote execution, which means that from a remote terminal, remote computer, it's possible to pilot remote applications. It is also possible to have many types of applications. I will not detail them, like database inquiry, sharing of files. Another one which is very important is this one, which is called here interactive conferencing. And I will come back on this type of application a little bit later, as well as a computer-mediated conference. This is a new type of computer application which is not possible without networking. So now you could ask me, it's, a network is something very nice, but how do I know to whom I could talk to? So you need some specific functions. One of the first functions to be implemented is the user directory. This user directory is a program running in one or several locations on the network, allowing anybody connected to the network to check if someone else is here, if someone else is not. When I say here, I don't mean physically working somewhere, but registered on the system. So it's some functions. For example, asking, is Mr. XYZ has Mr. XYZ access to the network? May I send him some mail? All the functions here are in the same spirit, and I will not detail everything. It also has a news capability, meaning that it is possible to broadcast the news, new features, to all interested people. Each time you access your system, so you receive the news from not only your own system, but from the network. For example, if somebody somewhere in another country has put a new program, if that person wants to make this program available, let me say, to the whole world, so it broadcasts a note saying, now you can use it, and it gives the, how to do. And as soon as you log on, you receive the information. So before telling you a few words about other US networks, I would like to show you what are the main characteristics of this network. First, who is allowed to connect on this network? All universities are university type of organization. When I say university, I include in this word all the non-profit governmental research organization as they exist in most of the countries. So all these organizations are allowed to use or to become member of the network. It uses IBM RSCS protocols. These protocols obviously run on all the IBM major equipments and also on some other equipments. It uses lease lines, as I said, and almost all the lease lines are at the same speed, which is 9.6 kilobits per second. And this is fast enough. It means about 1 kilobyte per second. And it's a fair amount of data that you are able to send per hour per day. The cost is simple. I will not say that it is cheap, but it is at least very simple to manage. The administration of the network is also it's not a big burden because, as I said, all nodes are equal. All the resources you may access are the resources put on the network by its users. No one tells you have to do that, you have to do that, you cannot do that, except for the first formality. What is the size today? It's, let me say, several hundred of mainframes. So as I said, this BitNet network is not the only one existing in US. I would like to just mention two other networks. Arpanet, obviously, because for two reasons. First, it is the oldest, to my knowledge, it is the oldest academic network in the world. It is not open to all universities. It's something different. It is open to all universities having a contract with the Department of Defense in US, which means that it is paid by the Department of Defense, not by the universities. It uses a different protocol, which is called, different functioning on the line. It also uses lease lines. and some of them are faster lines, depending on the needs of the labs. As I said, the cost is covered by the DoD, and it is purely US with no extension outside, with maybe some very, very limited exceptions of terminal access to the network. I would like also to mention and to finish with another type of US network. It is called CSNet. CSNet means Computer Science Network. The major difference between CSNet and BitNet is that, beyond the fact that the protocols are different, the technicality is a little bit different, but this is not the most important part. What is very important is that CSNet is used only for computer science needs. So this means that it is a really restricted network. What is, to me, very interesting in BitNet and also in EARN, as we will see later, is that the purpose of the network is to link all academic people without any kind of consideration to the type of work they are doing. And even more, the objective is not to connect, computer science specialists. In any case, a computer science specialist will find a way to connect themselves and to exchange information between themselves, because they know what is a computer, they know how to exchange information. What is important with BitNet and EARN is to allow, the physicists, chemists, biologists, etc., to exchange information, and to give them the same kind of benefit that the computer science people have already. So I don't want to extend this description of the US network. I wanted to use it as mainly as introduction to show you, if I try to summarize what we have seen until now, is first how a network can develop. It usually develops by growing around something which started it, like in CUNY, the City University of New York for BitNet. What is also very important to me in this kind of network is to allow all the people who need communication in universities, in public research center, to exchange information absolutely freely. The fact that it uses leased line with a one-time cost seems to me something very important, because you exchange information freely. You don't have to bother how much it will cost. You know that you have to pay such amount, and with such amount you buy, let me say, all the communication in the world. So now I would like to give you shortly a few other examples taken from European networking. As we will see a little bit later, all these academic networking efforts in Europe are now being, let me say, integrated or coordinated in EARN. What I mean is some activities in academic networking are existing in Europe since many years. For example, in UK, they have a network which was called CERC, I think, which is now called JANET for Joint Academic Network. It started, 7 years ago. And the Department of Education helped it to start. In Sweden, the same kind of network started 5 years ago. And these are national networks. The objective of these two networks is to link all the academic computers in the country, but only in one country. JANET in UK, SONET for Swedish University Network in Sweden. Some other countries had, let me say, less ambitious projects like France, Germany, Italy, where some smaller networks were existing. And when I say smaller, it may be smaller from a geographical point of view or smaller from a functional point of view. What I mean by functional point of view is linking either computing science people or high energy physics people, etc. Let me show you, for example, a chart showing what is JANET. JANET is also using leased lines with a different protocol, which is a standardized protocol used on these leased lines. And it connects, let me say, several hundreds of computers all over UK. By computer, I mean not only mainframes, as I meant when I described BitNet, but also minis and in some case microcomputers. So the numbers seems to be bigger, but the network is not bigger. Most of these very small computers are integrated in local nets. And this, as I recall you, as I said at the beginning, the objective of this topic is not to describe what is a local net, but obviously a local net may be part of a more global network. So, few words about the JANET technology and connections. 52 universities are connected to JANET. And to my knowledge, it represents, let me say, all the UK universities, almost all the UK universities. It connects 30, what is called other sites, are public research centers, which are not universities, like nuclear research centers, biomedical research centers, etc. It has a topology which is a little bit different. As we have seen on the previous chart, it has a ring. This ring has 15 smaller computers, let me say minis. The role of these minis is just to switch messages and files. And the real computers are all connected on these switching nodes. So the technology is different from BitNet, BitNet on this UK network. So this is the switches, and some they are linked by faster lines. And these faster lines are linking either all the switches or some really bigger computers outside this ring. And as I said, it has several hundred connections, and it was 230 by, I think it was mid-84. Another example of networking in the same spirit as Janet is a Swedish university network. In Sweden, you have 6 academic regions. Each region has a major center, and all these 6 centers are linked all together in a network, the center being in Stockholm. The technology of the network is very close from the UK technology. I mean, the protocols are almost the same. And this is an interesting characteristic in Europe. All Nordic countries have developed about in the same time, more or less advanced, but in the same, same time frame, the same very close type of networking activities. But again, it was only in the country. So the Swedish have this SONET network, the Norwegians have another network, in Finland it's another network, all the same type, but without any connection between them. So, until now, what I try to describe is a network technology which has been applied mainly in BitNet in US. Very briefly, the objective of such networking. I have also described few efforts going in other countries. So this, let me say, this concludes the first third of my presentation. What I would like to do now is to give you the results of the IBM experience in networking based on the IBM private network. After the third part will be the description of the EARN objectives and how this EARN project is, bringing all these pieces together to make a really worldwide network. So if you have questions on the first part, maybe it would be a good time to answer it, or if you prefer to wait until the end. It's, yes?
You haven't said anything about Euronet. Is it that you're going to include it in EARN or?
You mean Euronet?
Yes.
This is let me say, this is a slightly different subject. Euronet is a project at the European level which started a long time ago, maybe 5-6 years ago, and which is now, let me say, completed. Euronet as such does not exist anymore. It is, I was not planning to address this kind of network because, let me back up a little bit. By network, it may be meant either local net or wide area network. So we have seen the difference. It is also meant difference between transmitting coded information and using the information. Let me compare Euronet with the existing public data networks today. These public data networks are the possibility given in all countries to exchange bits without knowing the meaning of the bits. And my understanding of Euronet was the building of such a network before the countries which in Europe have built their own data networks, data communication networks. When describing EARN or BitNet or all the networks, I was not considering the technology below. And by technology below, I mean either the use of leased line, either the use of public data networks, and particularly in Europe. When I will describe EARN, you will see, or you will not see, in fact, because I will not describe the technology, but that many technologies are used. In some cases, in some countries, the use of public data networks. In many other countries, the use of leased lines. So to come back to your question on Euronet, Euronet was the implementation of packet switch communication networking on leased lines with, on top of that, the access of several databases like Diane database. But now this does not exist anymore as network. The database still exists and maybe used remotely using the normal data networks. Another difference is, as I see it, Euronet was a possibility from a terminal to look at a remote database. It is not possible with this kind of network to exchange files. For example, if I have the database somewhere, I cannot bring 1 megabyte of information from the database, bring it into my home computer. I may look at it. I'm not sure that I may change the information. To my knowledge, it was a database system. Does it answer your question? Yes?
I'm curious about one thing that I'm going to ask you. In these networks that you just mentioned, do they use generally the existing telephone lines, or they generally use a different kind of lines?
No, no.
Do they build a new line network?
They always, in all cases, they use the standard PTT offering. And by standard PTT offering, I mean either leased lines, a leased line being a point-to-point line connecting A to B, or a switched line, like the one you use when you telephone.
But is there any limitations due to the fact that they use the existing telephone lines on the battery?
Which kind of limitation?
Is there any limitation due to the fact that they use the existing telephone lines for the information exchange on the battery?
The limitation, you may have a speed limitation. A normal quote line allows you to transmit 48 kilobits per second on a dial line or leased line. But you may have a special quality defined by an international organism called the CCITT, allowing you to transmit 9600 bits per second. And if you need a greater speed, so you may use satellite lines. All these lines are normal PTT offerings, both leased lines and switched lines, both for normal telephone communication or for data communications. But what I mean is no special line is needed. Okay? So if you have no more question on this, I will survey briefly the IBM networking. And why taking this example? Because, let me say, 10, 15 years ago, we thought in IBM that exchanging information was vital, and that we wanted to develop a fast means of exchanging of information between, let me say, all the locations. And what I mean by all the locations means laboratories, plants, branch offices, everywhere. So this network is called VNet. I would like to tell you briefly what it is good for, what it does for us, how it has been built, how it grew, and how it is managed. I have to apologize, you will find in this set of charts many acronyms. You don't have to, the acronyms are not important. What is important is the functions. What I would like to show you on these charts is that VNet, we will find exactly the same parallelism with BitNet and with EARN. In fact, this type of network means two things. It means, first, the interactive use of networking, which means I am here in Izmir and I want to access a program which is somewhere else, for example in Paris. So I do it here. And the information, instead of going from this location to the next building, is going from this location to Paris and back. And this is what I call here the interactive networking. And inside the IBM network, it is called PVM, but PVM does not mean anything. So this is the first type of network application. The second type of networking application, let me say, is more classical and came first. It is a file transfer. What is meant here by store and forward file transfer is that if I want to transfer a file from A to B, it is not necessary to have a direct connection between A and B. The connection may be indirect. For example, it may be from A to C and C to B. And when I'm sending a file, let me show you here what I mean, if you can see. What I mean is, by store and forward is, if A wants to communicate with C, I do not need a direct line. What I need is a line, even with one, or why not 2, 3, 10 intermediate steps. So each time an information has to be sent from A to C, it is sent from A to B, and then immediately, or 2 minutes later, or 10 days later, who knows, from B to C. And I said 10 days later, it's not possible, but just to tell you that it has absolutely no importance. It may be in the next millisecond, it may be 10 minutes later. It depends on the availability of the telecommunication resources between both nodes. And what I mean by telecommunication resources are first the availability of the telecommunication line, the availability of both hardware and software on each end. So it is even not necessary, if I want to transmit information from A to C, it is even not necessary to have everything running in the same time.
Excuse me, sir. Isn't it possible to draw it with a wider line so that we can see?
Okay, you mean? Okay, and even this may be extrapolated, and any kind of topology is possible. So the only important thing to know when I'm sending information from A to E is obviously to know the destination, E, and to know the first step, and that's all. And it will arrive either in the coming microseconds or seconds or minutes, depending on the availability of the resources. So obviously, as I was showing you, this is BitNet, but this is also BitNet, this is also EARN. So I would like now to show you some statistics on this network. Again, I take the VNet example because I do not have yet good statistics on EARN. EARN is too young. And BitNet is not collecting statistics as well as VNet does. So again, this example may be extrapolated to EARN. This is for the, let me recall you that this network has two parts, the interactive part, and this chart is related to this interactive part. It gives you the number of nodes amongst all the VNet nodes, which are today about 1,600. Only 600 had by mid-84 the possibility to use this interactive facility. The session count is the number of sessions going in one of the major nodes in UK. The second parameter is the third one, median length, is also something interesting to show you the use, how people use it. As you see, they use it for a very short period of time. And basically, it is used when somebody is not in his office. It is used to check, is it something new in my office? This is certainly the most important aspect, at least in IBM. It could be different in a university environment, but at least in IBM, this is certainly the most important use of this interactive part of the network. Now about the profile. You see that very few sessions are long sessions. Let me tell you, this is two reasons. First, because where you are not in your office, you usually do not need to work directly, immediately with your computer, but also that the speed is quite different. When I have a terminal here and the computer is next door, I have not a 9.6 kilobit line, I have a megabits per second line. So transmission of information is immediate. I don't see the transmission of information. If I am using a network, even if it is a fast network, even if all the nodes are working, so the response time is not so good. And this is also a major difference. When I described here how is working a store and forward network, this cannot be the case for this interactive access. When you use interactive access, everything between A and E, if I am accessing E remotely from A, should be operational. And if it is not, if something is not operational, so I am not able to use the computer interactively. So this is for the second part of the network, and gives you also some interesting information on its use number of nodes. Let me say, this chart has been made in, let me recall, it was in June last year. And the number of nodes was 1,427. Last time I heard the size of VNet, it was early January, so 7 months later, and it was 1,600 nodes. So it's still increasing very, very fast. File count and size is, to me, is not an extremely interesting information because it depends on the type of application, and the type of application we have in IBM may be different of the type of application you would have in academic environment. What is, to me, a more important information, and you will probably find the same type of thing in all networks with the same technology, is a delay. It is very important, and let me say, VNet may have 10 intermediate nodes, say between 5 and 10 intermediate nodes, between one end and the other end. As you see it, 1/2 of all the files sent arrive, let me say, immediately, which means in the 20 coming seconds, which means that for that, everything should be working between both ends. And few of them take a very long time. And what does it mean? For example, I have 2% of files which need more than 9 hours. It means that something is broken somewhere. It may be the PTT, the telecommunication line, which is not operational. Maybe a modem, which is not operational. Maybe the line which is not activated. Something which normally should not happen, but which happens sometime. It may be also more simply that one of the computer in between is being maintained or repaired. But I think these two are very, very important. Half of the files are going immediately, and 90% extremely quickly. And how do we use VNet? Just few possible type of applications. For the interactive part again, it is possible to do something what I have not yet mentioned, which is not so easy but possible, which is load sharing. For example, I have two computers, A and B, with the same application. A is overloaded and B is underloaded. So from A, I may send data to B, requesting B to run the application and to send back the data. This is possible. It depends, it is feasible depending on the size of the information, input and output information, and also on the speed of the lines. Obviously, it is interesting to run such type of load sharing application only if for the application which do not have too much input and output data, which are CPU bound, not IO bound. Yes, project sharing is the same thing. Remote maintenance is the same kind of application. It's possible to run a diagnostic to see if something is wrong, both in hardware or software remotely. Access to home system, I have mentioned that several times. it may be used also to access libraries, and I have also mentioned that. What is possible to do with the file transfer part of the network? Mainly transferring files, as you know, as the name says, and a file may be anything, any kind of information, from a short message to a huge several megabytes program or book. And it may be used, for example, to develop the same project in several locations. So needing the exchange of big books, electronic books, programs, documentation, etc., etc. To finish this part, I would like to mention how it developed. And again, the two faces of this network. This one is the youngest part. And why is it the youngest? Because the easiest application of a computer network is file exchange. Interactive access comes after. So this came after. It started because of the need from a terminal to access a remote application. A first solution has been proposed 8 years ago by the IBM Research Lab in Yorktown, US. So it became used very quickly internally. As it was internally successful, it has been made available to as a product 6 years ago. And something which could seem surprising to you is that it used a transatlantic link since 1 year only. Yes, but before that it was possible to use the interactive access through the normal file transfer lines. It was not. This means that since a year, it's a dedicated line for this type of networking. And this tells you how the file transfer part developed. First, why has it been developed? Because of the need to work on the same project, to exchange what was called a job in that time. So an experimental solution came from one of the US labs and has been made available first in US 10 years ago and worldwide in 77. Has been made available, crossing the ocean 8 years ago, and in the meantime, it has become a normal product. First, a special product, and now a normal product since, 6 years, which means that let me come back just 1 second to what I said at the beginning on BitNet and EARN, saying that BitNet and EARN both use very simple and well-known and used since a long time protocols. And this is because it is exactly the same protocols which are used in BitNet, in EARN, and in the IBM VNet network. So we have shown these protocols for their simplicity, their ease of use, and it's why they have been adopted also by university. And again, to summarize, with the growth of both aspects, you see that it has been growing very fast. And if I should have written here January 85, it would have been 1600. And on PVM, I don't know, but I think that both numbers will converge, meaning that all nodes will have access to both possibilities. So I think that I have finished with this second part of the presentation, showing you how a big homogeneous network like VNet has developed. If I did that, is because it has been used as a model for BitNet and is used on a very different manner that I will explain you for EARN. So if you have some questions on this part, so I will answer them. And if not, yes?
Based on SNA.
No, it is based on what I call RSCS. It is much older than SNA, yes. It is BSC protocols. Yes, RSCS means remote spooling system, yes. And it is based using BSC, not SDLC protocols. The reason why this has been chosen is because it's running since, as you have seen, it started in 75. It's very easy to implement and easy to use. Nothing special is needed for the networking functions. And the growth may be simpler. So now I would like to discuss what is probably the most important part of this presentation, is how this US experience, how this IBM experience, how this UK, Swedish experience may be used to build a really multinational academic network in Europe, but not only in Europe, because it links today Europe, US, Canada, and South Asia will come also. You know, very soon it will be a huge worldwide academic and research network. So this is summarizing many things that we have already said. What are the benefits of networking? let's say the first, we have experienced in IBM that it is really beneficial to have this kind of possibility. And we believe that it is possible with such a network to develop, let me say, new concept of computer applications. And I would like to describe one of these, which is called here computer conferencing. Let me say that the other points here have been described. Before showing you what I mean by computer conferencing, if I come back to the beginning of my presentation, I said that one of the most important points in the scientific field today, or not only scientific, but particularly in scientific field, was the fast exchange of information. And this exchange of information should be a real exchange. It should not be a one-to-many type of information like radio, like television. It should be it should be interactive. It should be fast, and allowing people who do not know them to exchange information. I have a chart here trying to show you what I mean by computer conferencing. This may be a little bit difficult to, yes. This chart has on it all, maybe not all, but the most important means of communication between human beings. And here I have the time. This elapsed time is the time between the information is generated by the initiator and received by the other, at the other end. So you have it here. And here I have the number of people which are concerned by the information. For example, if I take my telephone, usually I reach the person. If the person is in his office, I reach him immediately. So this is very fast, but very limited. I talk to only one person. This is one end of exchanging information. It's fast, one person, and interactive. So it has two important characteristics: fast, interactive, but one drawback, only one person. At the other end, if I write a book, if I am a good writer, maybe 1 million of people will read it. But this is good from this viewpoint. Many people have access to this new information. But on the other hand, it takes a long time, not only to write it, but to print, to distribute. Let me say it takes 1 year. And it is not interactive. So on one end, telephone, on the other end, the book. And you may find on both axes other type of information, like radio, TV, which are supposed to be on the top here, very fast, lot of people, but not interactive. You cannot interact with your TV. You watch TV. On this axis, you have the mail, which is interactive, but takes long time, and is difficult to send to. You cannot send a letter to thousands of people. And if you do that, it is not interactive anymore. It's just sending information. But if something is missing here, here I mean fast, interactive, and access to many people. And this was really missing with the normal means of communication. And that's this gap, which is possible only, to my knowledge at least, with a special application of computer networking, which is called computer conferencing. Computer conferencing is following type of application. it's an application which is run somewhere in the network. It does not matter for me where it is run. It should be run somewhere. So I am a specialist in a very narrow specialty in any scientific field. So I first look at in a list, is it someone else interested in that very narrow specialty? It may be a very special case of, let me say, surgery, very advanced thing. So I look at my list. Is somebody interested? If yes, so a conference with the name ABC is already open. So I register myself as interested in subject ABC. And as soon as I am registered, I know that 10 people all over the world and in 10 different locations are also interested in the same thing. And I have immediately not only their names, but what they have contributed on this subject. So this is, immediately they will know that someone else is joining their club as soon as they log on in the system. So normally, if I am working in a very narrow specialty, I have to know by name and by address all the people in the world working in this domain and running workshop with them, etc. So now, let me say, a conference is an electronic workshop. Now, if no one has built a conference on this subject, so I put the name of my interest in the list of conferences. And if I am the only one in the world, so nothing will happen. But it's more likely that very soon you will find that other people are also interested in the same subject and will come to you and will exchange information with you. And again, what makes it very different to me is that you may exchange information with people that you do not know neither by name nor by address. You will know their name and address later. So if I insisted on this type of application is because I believe that it is something really original that cannot be made without a computer network. Yes, again, a very brief summary on the technology of all these networks. They all use, by all I mean BitNet, VNet, and for most of its parts, EARN. They all use leased lines, and most of them use 9.6 kilobits line. Why that speed? Because it's a good, let me say, can't find the right word. The speed is, it's fast enough and the cost is not too high. And it fits, it's optimal, usually. However, if you have a very small amount of information to transmit, you may use 48 or 2400 baud. If you have a huge amount of information to transmit, so you may use a satellite channel at 1 or 2 megabits. And they use the RSCS BSC protocols. So, what is now? I would like to describe the reason, what is EARN, the reason of EARN, how it's possible to join EARN on all matters related only to this European network. First, who may be part of this network? I'm sorry, it should be me. It is open to all European universities. And again, universities include all the public research centers. It is not specialized. I mean that it is not a computer science network like CSNet in US. It is not restricted to people working on high energy physics, like a pretty big, not big by the number, but by the speed of a network built in Europe around CERN. It is both international and not specialized. And if I'm insisting on the fact that it is both not specialized and international, is because before EARN, the other types of network, I mean either national, as we have seen in US, in UK, in Sweden, were existing, or some specialized network, particularly between science, computer science people or high energy nuclear research people were existing. But to my knowledge, BitNet in US and EARN in Europe are the real first academic general purpose networks. So, a question could come, what is the IBM involvement in this network? And before that, why is IBM helping the universities to build a network? You may know that IBM has always found many ways to contribute to the university work. This has many, many aspects. Just to tell you a few aspects of this contribution and this cooperation between IBM and universities. In some countries, it exists what we call scientific centers. It is some small scientific centers, as I said, working in a very close cooperation with universities in their country. And it's maybe half a dozen in Europe and 3 in the States. IBM is running institutes, and these institutes are the gathering organized by IBM of very high-level specialists in many fields. What I mean by many fields is usually not only computer science field. It may be earth resources, it may be medical applications, etc. It's not restricted to computer science. Another aspect of the IBM participation to the academic life, let me say, is the organization of exchange of professors between universities and IBM research centers. For example, in the biggest center, which is in Yorktown in US. So just to tell you that since the beginning, IBM has interacted with universities and helped universities. So let me say 2-3 years ago, the IBM Europe management wanted to find a truly international project which would be difficult to build in only, let me say, which would be difficult to build by the universities themselves in the countries. The field which has been chosen is the exchange of information. And why? Because it seemed to us that it was certainly the most important and the key of being a winner as a nation, as a university, is to have very fast information. So we wanted this project in the information technology, and we wanted to be really European project. So this is the reason why we have become involved in EARN and helping the university to build this project. So this is just to summarize what I was just saying. Started, 2.5 years ago. It was important to start it quickly. What does it mean to start quickly? It means that it should be simple. It should not be such that you need 1 year to learn how to use it, etc. It should be available immediately. Even though it's not so easy, as we will see. It should be a European, but it should not be uniquely European, because science is not European. Science is not American. Science is worldwide. So, where are we today? I have a map showing some countries, not all, and particularly it does not extend in Turkey, I'm sorry about that, but some other countries are missing also. The reason is I wanted to show where we are on January 1st, 1985. The red lines indicate the active lines. And today, 8 European countries are connected. 8 countries are connected on this network. If I start here, you see Denmark, Germany, Ireland, Switzerland, France, Spain, Italy, and Israel. And and 2 lines are connecting EARN to BitNet. This is just for, let me say, for historical reasons. What I mean by historical reason is the delay to install a line may vary, is function of several parameters, such as the possibility for the PTT to install the 9.6 kilobits line, and this kind of delays that in some countries we were experiencing. It happened just like that, that southern countries were connected to US. Networking was starting to develop in Northern Europe countries without the connection between them existing. So we decided to have another line between Germany and US, which has been possible to have in 3 weeks, I think. So now, if I want to communicate today, between, say, Darmstadt in Germany with Rome in Italy, I have to go through Washington, D.C., New York, and back to... But this is a temporary solution. Very soon, in principle, this month, we should have the missing link here, and several other missing links here, there. And that means that as soon as all the countries which wanting to connect to EARN will have joined the network, so it will be necessary to reshape this network. Yes? This is, this...
For example, Istanbul just belongs to Greece, and Edirne belongs to Greece.
No, as I said, the map is not accurate, and your country is missing, but it is not the only one.
Not the missing money.
it's
You transfer some part of Turkey to Greece. And Greece is a border to the Black Sea.
yeah, I have to apologize for that. Yes, it's a schematic. It's not a map. It's not countries. No, yeah.
Another part is just correct. If you look Sweden or Swiss or Germany, any mistake there.
Okay, after
Yeah,
the
you-
conference, we will have to correct this.
Yes. But let me again apologize for that. I hope that it is the only mistake on my list. So as I said, where we were at the end of last year, 2 months ago, is these countries were wanting to join the network. And you have the list here. Among these countries, 5 were connected. I mean on December 31, 84. And yes, some networking activity which is not part of EARN, but wanting to connect later to EARN was starting in Saudi Arabia. And now, where we are today, or where we were last Friday, I don't know if something new happened this week, is, as I told you, 8 countries connected. And now let me show you what I'm expecting to happen between this year and next year. It's a connection of all countries, including Turkey, to EARN. And possibly, this is, I believe that this is a very high probability because, you know, due to the need of such a tool and the interest, maybe later, I see, you know, this is, it's at least my personal view. I see this happening this year in 85. This happening in next year. I mentioned here network management because this is, I will not discuss that here, but when a network becomes bigger and bigger, so even if it is a very simple to manage network, so it introduces some management constraints. So before finishing this presentation, I would like to mention a few words on how this network is first, what we would like to do with this network and how it is starting to be organized. So this, I believe that it is not enough to establish communications between computers. If you do that, it is certainly the easiest part of a network. So you have a network, so what? What is important is the next step, is to apply it to all technical fields and to show to people who are not yet accustomed to use this means of transmission of information to use it, because we believe that it is something which is very important for them. Something which probably, depending on the success of the network and on its use by non-computer science people, probably it will need to use satellites very soon. Now a few words about organization. Exactly 1 year ago, I think it was in February 84, it has been the first meeting of the EARN members. And they decided to formally build a committee. And this committee is called the Board of Directors. It is the same terminology that the one used for BitNet. It is an international committee with one representative per country, one university representative per country. And they decided that it was necessary to have several, not only a chairman, obviously, but several committees. And you have here the list of the today's committee. And the chairman is somebody from the CERN, which is the European Nuclear Physics Center. And 5 technical committees. One is a real technical committee, which defines what should be developed to have EARN running as well as possible. For example, node management, users management, computer conferencing, these kind of things. This committee has to deal with which type of communication should be implemented on EARN. As you have many computers, so the problem of having everybody understanding all the other partners becomes very important. As we are using the resources offered by the PTT, so we have to coordinate the activities in this field. For example, what the shape of the network should be, etc. All matters related to PTT is coordinated by. Okay, this is CERN, I mentioned it. This is a UK lab, also in nuclear research. This is the same person. GSI is in Germany. Next committee is promotion. As I said, it's very important to advertise the network, to tell people, here is a facility, you may want to use it. The chairman is from the University of Montpellier in France. Last technical committee is to find, it's a little bit related with this one, is to find application which most benefit from networking, new application in new fields. So what I would like is now to finish my presentation by a very short, should not say summary, but highlighting the most important points. First, it is open to all, and I should even remove European, because it will probably extend well beyond Europe. Open to all academic and research institutions around Europe. It is open to all computers which are able to communicate with RSCS protocols. And it is users managed network. What I mean is that IBM is helping the universities to build this network, but IBM is not at all managing the network. This is under the user's responsibility. This is built on the following manner. EARN has defined a board of directors with one representative per country and one CERN representative. Why a CERN representative? Because CERN is a really not national, European organization. Let me say what is the most important contribution of IBM to this project is to fund the international lines. So this is the, let me say, the major contribution that our company gives to this project. So this is what I wanted to tell you. Maybe you have some questions. Yes?
As far as I understand, the association has been established a few weeks ago, 2 weeks
Yes.
ago. Now, since you call it an international organization, and again, as far as I know, every international organization needs an umbrella. Means either United Nations or a particular government or European Common Market or something like that. What kind of umbrella EARN has?
It has no umbrella. The board of directors met 1 year ago without being formally defined. But for several reasons, they decided that yes, it was important to have a legal association. This association has been created, and it has been incorporated in France. Why in France? It's no good reason, because the French regulation is easy for this type of association. It's easy to create an association, but it has no sponsor.
Yeah, but since it's a French association legally,
It is, yes.
now if, I hope it won't happen, but if we have some friction with France, and if we are a member of EARN, since it will be a French organization, legally, they can cut us off.
No, absolutely not. No. The reason why France has been chosen is because it is very easy. For example, the French government cannot look at what is an association, provided that this association follows the rules of the French, follows the French law. That's all.
Second question.
But yes, it is financially, the association has the right, the legal right, to raise funds if needed, to handle money. But today, it is not the case. I mean that the lines, as I shown you at the beginning, in most of the cases, the telecommunication lines are paid either by IBM if it is an international line, or in the country, each one computing center, paying for one line. So EARN do not need yet to handle money. But what I have not yet mentioned is that the IBM support for this project is until the end of '87. So yes, after the end of '87, it's coming pretty fast. It's less than 3 years now. EARN will have to manage, EARN as a body, will have to manage the network and to manage the payment of the lines. I think it's different. It's easier in the States where the cost of a line is roughly the same going from one city to another. But the cost of the line, if I take the example of Italy, the cost of a line going to the States is very different of the cost of the line going to Spain. So the EARN board of directors will have to manage that later. Yes?
So I have two questions in fact. Perhaps you can change the order of answers. One is it not a deviation from the standardization, where there is so much effort put into the standardization? Second is, what are the technical requirements of the EARN on the network?
Okay, yes. I think your first question is, I should have addressed this subject. You know that it is presently a big effort of defining internationally communication protocols. And this is made by two major international organizations. One is the CCITT, and the second one is the ISO, International Standard Organization. And they are both defining the same, working really in parallel together, defining the same set of protocols. And this work started several years ago and is being progressing. But this work is not yet completed. They have defined a model with 7 layers of protocols. Now the protocols are being defined, so from the bottom to the top. But if I want to run a real application, I cannot today use OSI protocols because they are not yet defined. So it is two possibilities: either to wait for communicating, wait until these protocols are defined, and it does not seem very reasonable because the need of exchanging information is today, it's not 3 years from now. So it seems that it is not a very reasonable position. The second possibility is to use what we have today to build what we will have tomorrow. Let me take the German example. In Germany, they have a big project, OSI project, for universities. Many universities want to develop their OSI protocols, and this project is called DFN. Don't ask me what it means. It's a German acronym. And EARN in Germany is seen, which is developing very fast also. About 80 nodes are implemented and running today. EARN is seen as the first step going in the DFN and OSI direction. And the board of directors has, as you have seen, a committee on standards, and it has openly said that they will go in the OSI direction as soon as it is feasible and that the protocols are built by the manufacturers. So does it answer the first? And your second question was, I'm sorry?
The technical requirements of joining.
Oh, okay. Technical requirement is to have a telecommunication. Okay. First, it is necessary to develop, let me say in parallel, two things. First, a national network. And to attach this national network to another international EARN node. Okay, why proceeding this way? Because connecting, it's either you could connect one university in one country to another university in another country. But this would not be very good for, let me say, for example, the other university in the same country. An international telecommunication line is something quite expensive. So the objective is to have it for the benefit of all, of the maximum possible, the greater number of universities in the country. So what I would say to build, for example, to bring EARN in Turkey would be to build in a national network between the major universities and to connect this Turkish network somewhere. And somewhere means where it is already an EARN node. and where it is, I don't know, the cheaper line, the easiest to get line, and using 9.6 kilobits a line. So this is for the organization requirement. For the technical requirement, what is needed is telecommunication line, 2 modems, running on both ends the RSCS protocols.
You propose a node, different node, like in Arpanet.
Excuse me?
Do you propose a node like in Arpanet for each site?
No, the node is the main computer. It does not need a smaller computer as front end. The line is, let me draw here. Here it is. What if I have here a computer A, I want to link it to computer B. So what I need here is some kind of equipment to handle telecommunications that we call telecommunication controller, such as the IBM 3725, 3705 here. You need the same kind of equipment here. Now you need a line, but this line is analogic usually. This is digital. So you need an additional box, which is a very small box, and it is a modem. So if on the computer A or B, if you already have terminals, so you already have this box, it's needed for any type of telecommunication. So the additional resources needed to communicate between 2 computers is an additional pair of modems, if you do not have spare modems, and the telecommunication line. And also the software, the RSCS software. Yes?
You know, sir, I'm interested in the practical aspect of the network, and my question may be stupid, but I will go ahead and ask. Suppose I am in Istanbul and I'm going to run a program which requires data from Paris and say from London, and my computer does not have enough physical memory to run my program. Is it possible to run my program to a bigger computer in our network?
Yes.
What are the problems involved when we require to use somebody else's computer and take the physical real time?
Yes, yes, suppose that your computer here does not have enough CPU power, for example, or enough space. So you may bring the program in a remote computer, and a remote bigger computer. What you would send back and forth are the input and output data. So this is certainly possible for a program needing a lot of computing power, maybe a lot of disk space, but with very, very few input and output. What I mean by input and output is for the human being, you know. If it is the case, yes, you can run it remotely. On the other hand, if you have a program which needs a lot of interaction with the user and very few CPU, so it is not worthwhile to run it remotely. But this is possible, and this is part of what I call the load sharing, for example.
Provided the code conversion is okay.
Provided that the programs are compatible. Sure, yes. But even it was I don't know if it is realized in some specific case, but using the time difference between either two countries or two parts of a big country to run when a computer is less loaded during the night, so to run application from people which are in the normal working hours.
You know, once you be a member of the network, it is accepted the fact that we can, after that, we can use the computer without paying extra money for the...
No, what the network gives you is a possibility to communicate. But let me take an example. Yes, no, the time for commuting files is very, very low. Let me say it's depending on the size of the computer, depending on the number of lines. Let me say it's between 1 and 5% of the CPU cycles. It is not a priority job. I mean that if you have a priority job, it runs before the telecommunication application. So you may allow your system to delay messages if you have something very urgent. So this is, let me say, you have it for free. What you do not have for free is the running of a remote application. Suppose that today you are here in Izmir. You are sending tapes, say to Istanbul, where you have a bigger computer running a special program. So you send the tape by the mail, the tape is run, the computer runs your program and sends you back a tape. So afterwards, you will probably receive a bill from Istanbul saying you have used 2 hours of my Istanbul computer, so you have to pay so many liras. And this will stay. What you will get for free is the exchange of the tape between here and Istanbul and back. And it will be also faster, but you will still have, if today you pay for the computing, the CPU cycles on your program to run your application, you still will have to pay for that.
But is there any inclination to make it free, among the network?
This is absolutely independent of earn. If in some countries, let me take an example. If in one country all the computers are paid centrally by a central administration like Ministry of Education, so it's no need of back and forth billing. If all universities have their own budget, probably they will bill each other for the use of resources. This is not an earned problem, you know, it's an...
With another university in another country that you pay nothing, but if you don't have this kind of thing, that you have to pay. It depends on correlation to universities.
Yes, yes. It's like another example. If some university charge for sending reports, some others do not. So machine time is the same kind of management.
You must create some research project with another researcher from our university that you pay us.
Absolutely, absolutely.
So this is a joint project.
Yes.
Since you put the Turkey on the projector, apparently there is a kitchen work prepared so far for joining Earl.
This,
Can you give an explanation about that one?
let me say, this, the objective of this project, as we see it, is to connect all European countries this year, obviously including Turkey. So this, it's a reason why I am here. As it is my responsibility in IBM Europe, I would like you joining this project as soon as possible.
It's a good deal, nothing else. It's a good deal you are saying.
Yes, and
To join the Earl.
this goodwill may be what IBM will do in this case is what we have done for the countries already connected, is funding the line connecting Turkey to another country. On your side, it is, I think, necessary to, to do two things, to organize yourself in order to attend the board of directors meeting and to organize your own national network. And this may well be the first EARN Turkish meeting here today.
What you're saying is that you should have first your own national link or national network. Is it a must?
It is. It should be developed in parallel. Yes. It must be developed in parallel, in the same time frame. If the international line comes 2 weeks before or 2 weeks after the national line, it does not matter. But certainly not 1 year.
Sorry, I was intending to save my question later, but why I asked whether you're proposing a node for a university is that is one point that there are so many protocols available, or there will be a standard, protocol.
Yes.
Will be accepted by many countries or organizations. Now, having that in mind, one should be careful to have a facility, a manufacturer-independent facility, perhaps, at each site, so that it would be easy to switch from one protocol to the other, or use as a gateway.
It's never easy to switch from one type of protocol to another. So let me take the example of EARN today, which is running with RSCS protocols. And RSCS protocols is implemented on several types of computers, not only on IBM computers. So on that sense, EARN is already an open system, not in the sense of OSI, but I mean it is not restricted to one type of computers. So it's somehow open. And if either a part of EARN, like the Swedish, as I said, the Swedish or even the UK networks are using different types of protocols. So they have a gateway, yes. A gateway being a program translating protocols from one protocol language, RSCS, to another protocol language. So if you look at what will happen in the coming years, I believe that OSI will develop, and EARN has already said that they will go in that direction. How is it possible? I cannot tell you, but my personal belief is that first, OSI will be developed using EARN as a bootstrapping facility. This is at least what is expressed by the EARN people. And when all the OSI protocols will be defined, when they will be implemented on all the computers, and I mean not only IBM, which are today part of EARN, today or tomorrow part of EARN, so the transition will come. But I don't think that the transition will come, next year. But this is the objective, and many countries are working in that direction, like Germany. I did not mention Italy, but Italy has also an OSI project, which is called Osiride. France is about announcing the same kind of facility. So during a period of few years, both type of protocols will develop in parallel.
Well, I think the protocols are defined by CCITT and implemented by contractors.
The protocols are defined by both CCITT and ISO, yes. But today, only the bottom layers are completely defined. And running a computer application needs all. Yes, exactly. It's a plug. The plug is defined, but what you do,
Well,
yes.
there are countries using X25 lower 3 layers.
Yes? Yes, but this is not enough. This is not enough to exchange information. Let me take an analogy. X25 allows you to exchange in a standardized way bits, piece of information, but not programs, not human being information. To exchange human being information, you need the top layers. For example, the CCITT has defined at the end of last year, during the end of the last CCITT period, a message exchange standard protocol. But you know that it takes quite a long time to develop. When a product is defined on paper, it takes quite a long time to implement it. I don't think it's a standardized file transfer protocol. I don't think it's defined by ISO. It.
Well, UK has its own version.
Yes, exactly. The colored books. Yes. But this is not yet. This is not internationally accepted. No.
Thank you very much, Senator Auroux, for your interest in the seminar. And the end of the seminar, we are inviting our center. And also, there's some coffee, if you accept our invitation, this some hours, and also we can discuss these problems. And the second step is we hope that about the final 20 days later we will invite the other university to make Turkish committee, and after we will try to join the project. Thank you very much.